Good day, students. Today we will be touching on functions. Now, functions is actually one of the biggest topics in mathematics. It is the most important as well, and this section of functions, or this playlist of functions, which I'm going to put in my playlists, is going to help you from struggling with functions to actually understanding everything from the basics of functions. So if you are in grade 11 and you still do not understand the fundamentals of functions, well, I'm glad you came to the beginning. So I'm going to explain it in detail from the beginning until the end. So in this video, I'm actually going to introduce functions to you. I'm not really going to do anything further than just introducing it to you. Now, when we talk about a function, right? Think about a spider diagram. What does a spider diagram look like? I will pause the video and just continue to wherever I draw the spider diagram. Let's draw the spider diagram. Aha! You probably thought I was actually going to draw an entire spider diagram. We don't even have to do that right now. I'm just taking a portion of it with basically just two legs at this point. So, let's look at this, right? You're probably familiar with this from primary school or just primary school basic math. Now, what do you think is going to happen with this? What is going to happen with the 3 to make out 6? Now, let me just label everything for you so that you can understand this into detail. What is this 3 over here indicate? This 3 over here indicates the input. So, what is that supposed to mean? It is a number that you input into this whole diagram. That's the number you start with, right? And now, what does this 6 indicate? Can you take a guess? This 6 indicates the output. What does the output mean? It's what you come out with. It's going to be the final answer, basically. That 6 is the output. Now, can you take a guess? Okay, first of all, let's actually just complete this diagram. What is supposed to be in this block over here? This block over here, we know that in order to get it from 3 to become 6, we need to multiply by 2. If we multiply 3 by 2, we will get an answer of 6. Now, what do we call this block in the middle? This is actually, there we go. This is where we know this is the function. There's actually two ways that we can actually interpret this. This middle one is called a function, or you can actually call it the process. This is the process it takes, or this is the process it undergoes in order for the 3 to become 6, basically. What does the 3 need to do in order to become 6? It has to multiply by 2. That's a process that it undergoes. Or we can call it the function. But we are mainly focusing on the function in this case. Let's do okay, so we have done the diagram, right? I'm just trying to introduce you. These are what textbooks would normally show you. Textbooks would show you spider diagrams, or some textbooks, I guess, would show you just a singular diagram, but I think that's actually rare, to indicate what is the point of a function. Now let's get into actual functions. What do functions look like? Let's just get straight into that. Okay, now we are going to give an example of a function. Now, what example can we use? If you look in your textbook, or if you look in your notebooks from where your teacher gave you examples, a function would actually have an equation as follows. It would have f of x. This f bracket x just will be read as f of x, and I'll explain why. You would have f of x is equal to, then they would have some linear equation which will be as follows. Let's say, for example, we give you an equation x plus 1, or an expression x plus 1. Now, let's actually do the following. So the reason why I actually gave you the spider diagram, or the diagram in the beginning, was to actually show you this method. Now, let's say for example, and stick with me for now, and you'll understand after we do more examples. If I give you, or if I ask you to find the value of f of 1. So, as you can see over here, right? What does this f of 1 over here look like within this equation over here? Do you not agree with me that f of 1 is similar to f of x over here? But what is the difference? The difference is that there's not an x in the f of 1. It's now a 1. The 1 is being replaced by x. Now, this is actually what you call your input. You are basically just inputting the 1 into the f, the function. And how is it going to process? Remember, like in the diagram I showed you, there is an input, then there's a function or process, and then there's an output, obviously. So what is going to be the function or process of this equation? If you said that it was going to be this one, you are absolutely correct. Now, why is it that one? I'm going to write it here. I'm going to actually scroll down quickly, and let's actually check this out. I'm going to write an arrow here, indicating that we are going to write f of 1. So let's look at f of 1 as our input. We have inputted now a 1 in place of x, and we are referring to the same equation over here as here. Now, what does that 1 mean, right? Remember that now the process is actually where this 1 will replace all of the x's. Note how in this one, the 1 has replaced the x. So on this side of the equation over here, on the right hand side of the equation, you will actually just replace all x's by 1. So what is x over here? We know that x lies here, so we will replace this x by 1, or with 1. And as you can see with the 1 over here, can you see the plus 1? This plus 1 will not change at all. Why? Because it's not a variable, it's just a numeric value. And numeric values actually stay constant, they stay the same. And guess what? Do you want to know what their names are? Those are just referred to as constants. So as you can see, the plus 1 does not change at all. So what is this? 1 plus 1. Now as you can see, we can actually have an answer. We can find out what the answer is. And what is 1 plus 1? That's just equal to 2. Now, why on earth did I do this? Let's show you. The first part of the equation that is right over here, f of 1 is actually our input. I'm going to write it as small. This is our input. Now what is this 2 over here? This 2 is what we came out with. This is the answer that we have. This is our output. I'm going to write it as small over there. That's our output. Now, in the middle, as you can see, it's basically the only last thing that you can see. This has to be our function. I'm going to write it as small there. That's our function or our process. So, let me summarize that. We have inputted a 1 in place of the x. Now, in the middle, on the other side of the equal sign, the first equal sign, we have replaced that x with the 1 that we have put in. That is the process that it's undergoing. And in this case, we call it the substitution. We substituted 1 into x. And now on the last side, or on the far right hand side, we have the output, which is 2, because 1 plus 1 is equal to 2. That is our output. It's literally the exact same as the diagram that I've shown in the beginning. That's what I'm trying to refer to. Let's just do some more examples, and then we can call it there. And then the next few videos, I will begin to do questions on functions after you understand the introduction. So let's move on to examples. Okay, so as you can see, what I have given you an equation. Now, normally when you are in an exam or something, they will say given the equation, or just given f of x is equal to 3x minus 2. Okay, there's our function. So this is an example of a linear function, which is going to be the first function that I will teach you. That is not important at the moment. For now, let's just understand this question that they are giving us. They say, determine the value of f of 2. Now let's try and see what they are asking. Can you see that they want us to determine the value of f of 2, right? But as you can see, f of 2 is similar to f of x in the equation, which means, once again, as I said previously, when you are given a question like this, like let's say f of 2, you need to replace the 2 with the x in that specific equation. Now let me show you what I mean. Let's do this example right here. We have f of 2 as our input, right? We are inputting the 2 into the equation over here. I will write it as I. This is our input. Now, our function, how is it going to process all of this? Remember, in this equation over here, we have 3x minus 2. Now, we know that the 3 will stay the same in this case because obviously that is not our x value. So let's write 3 down. Now, as you can see, next to the 3 is the x over here. There's an x. So what we are going to do, when we replace the 2 with the x, as you can remember, that's what we are going to do. You must make sure that you always place it in brackets. Because it's just, if you place it in brackets, it's actually easier to get the correct answer in this case. Because if you don't put it in brackets, it's going to look confusing. And as you can see, this actually looks the exact same because you have 3 and brackets 2. This is actually just 3 times 2. That is how you can easily tell the difference. If you have brackets, it'll make it much easier to read. And as you can see, the last part of the equation is just this negative 2 over here. So let's write minus 2. And remember what I said? The minus 2 does not change. Why? Because it stays constant, and it is called a constant. Now when you are writing it in the examination, and hold on, let me just write this down. This is our function. I'm going to write it as f. Or, you know what, let's just do this over here. I'm going to write equal sign over there. What is this? 3 times 2 minus 2. What are we going to do? Remember, BODMAS comes first. 3 times 2 is equal to 6. And we are still left with minus 2. And now, that answer, I'm just going to write it here. 6 minus 2 is equal to 4. Now, as you can see, 4 is now our final answer. This is our output. So, let me just actually write OU because it looks like just over 0. So, as you can see, we started from f of 2 and we ended at 4. As you can see, this f of 2, we have clearly inputted a 2 in place of x. For the function from the left hand side as well as the right hand side, the equation or the expression. Let's do one more example and then we can call the video from here. And then it should get consistent. Okay, very funky handwriting right now, but let's actually just look at this question. We are given g of x. Okay, haha, look at this. You don't always get f. The reason why we have g in this case and not f, remember f would stand for function, right? That is our standard abbreviation for function. Now, with f, we would just write it as one function. But remember, or not remember, just take note that we don't only write one function down. And when you see the example, or if you see the later on videos where I actually do 2 functions at a time, you'll see that I won't be using f only. I would also be using other letters. And that is what mathematicians have done. We have also decided to use other letters. And as you can see, g comes after f. So that's exactly why we also say g as well here. Anyway, just take note that the functions don't always have to have f of x. It can be other letters. That's what you just need to know for now. So we have g of x is equal to x squared. Okay, So this x squared is a different function, but let me not actually name the functions now. Let me actually just stick to the basics, and once you get further, you will see what the function is. Now, we are asked to determine the value of g of 3. Now, with g of 3, you can see that g of 3 over here is the same as g of x, basically. The 3 is just different. They want us to find the value of g of 3. Now, let's just answer this question. But let's answer this question as if we were answering in the examination, or if we were answering as homework. Let's write g of 3 is equal to, let's look at our equation. We have x squared over here. With x squared, we know that we need to actually replace, in this case, we need to replace all the x values in the equation with the number 3. Because that is what our g of 3 stands for. We are inputting 3 into the function, and then the process is that the 3 is replaced with every single x in the equation. And then the output will be the numerical answer, obviously, the numerical value version of the answer. That is what functions is. So, right here, we have x squared. Now, how do we write this down? We just, remember what I said? When you substitute or when you replace the number with x, you write it in brackets. 3 over here. And obviously, we are still left with square over here. Now, what does this give you? I'm going to write the equal sign here. This is how you should write it when you are answering questions. With g of 3 will be equal to, what is 3 squared? 3 squared is just equal to 9. That's about it. Yeah, that's the answer. So, we can say over here that g, okay, let me not write the dots now. We know now that g of 3 is equal to 9. And that is our value of g of 3. As you can see, this is the introduction to functions. And then the next video, I will be going over linear functions. What is that? You will find out in the linear functions video. Thank you so much for watching. And yes, you will learn more.